Hello and welcome to this NDAR Naval Architecture video, part of the NDAR video library. This video features the Orca3D plugin for Rhino 3D V8, created by our excellent partners at the Orca3D software house. Orca3D offers a complete set of naval architecture tools. In this video we'll review and explore the Orca3D Hull Assistant toolset. The Orca3D Hull Assistant toolset is designed to generate early design hull models in a short time, thereby allowing various naval architecture and design activities to be carried out in parallel from the earliest stages of the design cycle. The end goal is to fully validate the design in the shortest possible time. More videos addressing the overall design ecosystem are available from the NDAR and Orca3D video libraries. This video is divided into 6 sections. Create a new file using the Large Objects Meter template. Here are the target values of the hull's main particulars and coefficients that we seek. Now we will set some Rhino and Orca parameters. From the Tools pull-down menu, open Options. In the Units panel, set Absolute Tolerance to 1 mm, the Angle Tolerance to 1 degree, and Display Precision we will set also to 1 mm. Model units are already set to meters as we have used the Large Objects Meters template. Click OK. From the Orca3D pull-down menu, open Properties. Change current units to SI ton. Set model orientation forward to +X and up to +Z. In the Hydrostatic tab, leave fluid type as seawater and keep the rest parameters with default values. Click OK. From the Orca3D pull-down menu, open Hull Design, Hull Assistant. There are 5 types of hulls which can be designed with Hull Assistant. For the planing hull, we will choose Default Planing Hull Assistant. Open Assistant. Change the description to Planing Hull. There are 3 tabs in the Planing Hull Assistant window: Dimensions, Shapes and Angles. We will start with main dimensions of the hull. During the design process, we would like to see the current stage of the shape, and changes were produced by changing the different parameters. Check the Preview Hull checkbox. We would also like to see the sections. If necessary, custom sections can be defined. We can also get a live preview of 4 selected hydrostatic parameters at a time. You can choose parameters from a list of available parameters. We will choose Block Coefficient, Water Plane Coefficient, Displacement and Vertical Position of Center of Buoyancy. Set Length on deck to 45 meters. Beam on deck to 8.6 meters. The target value for the draft is 1 meter. All vertical dimensions will set from the design waterline. Deck height at the bow and at the transom are the corresponding elevations of deck above the design waterline. Deck height at bow will set to 3.65 meters, and deck height at transom to 3.3 meters. Chine height at bow set as 1.6 meters. By default, seaplane origin is located at the intersection of centerline, draft waterline, and forward perpendicular. We would like to change so that it will be located at the transom and at the level of design waterline. To achieve this, we need to shift the hull forward by 45 meters. Keel height at transom will be negative and will correspond to the desired draft. Set it to -1 meter. Moving a slider corresponding to keel height at transom, you'll notice that shape is changed and hydrostatic parameters will change as well. Set the chine width to 0.15 meters. We will proceed with the shape setting. Switch to the Shape tab. The shear height is a fraction of the deck height at bow and shear height position is a fraction of the length on deck. We'll set them as 0.88 and 0.6 correspondingly. Deck beam at transom and chine beam at transom are fractions of the beam on deck. We'll set them to 0.9 and 0.85 correspondingly. Maximum beam position is a fraction of length on deck and will be set to 0.45. Forefoot shape allows to change the rounding between the keel and stem. Set it to 0.5. Bow fullness and bow rounding control the deck shape near the bow. As the bow rounding is increased, the deck edge becomes more perpendicular to the center plane. As bow fullness is increased, the maximum deck beam is carried further forward. We'll set them to 0.5 and 0.6. Bow twist controls the bow twisting ratio. Set it to 0.4. Switch to the Angles tab. Bow rake angle will set to 30 degrees, as desired. Bottom rocker controls the slope of the keel line, we'll leave it 0 for the horizontal keel. We'll set the transom rake to 0 for the vertical transom. Transom and mid-dead rise control the angle between the bottom part of the frame and the base plane. We'll set them both to 12 degrees and we'll set transverse chine adjustment. As you can see, hydrostatic parameters values are higher than planned. So, we need to slightly change the definitions. We choose to intervene on the transom and midship dead rise parameter in the Angles tab. We will change them to 13. Thus, we have matched concept target values closely enough for this hull to be used as base for ensuring design work, to hydrostatic initial check, compartmentation and damage hydrostatic, CFD, 3D general arrangement, preliminary structure layout, seakeeping, etc. Save settings. Now we can create hull. Open the pull-down menu and select Create Full Model. This concludes the presentation of the Hull Assistant toolset. Thank you for watching this NDAR video featuring Orca3D.